This is the digital audio amplifier with integrated digital signal processing. This amplifier is designed for the home theater market. We're trying to come in at the lower, more affordable price points with high-end quality. So those high-end amplifiers might be around $4,000, and they'll be high quality, but at the lower, $1,000 price point and lower, we're hoping this prototype could become a $700, maybe $600 product to the end user. And so kind of what we provide for that high quality audio is in the digital signal processing, Class D amplification, and the digital inputs. And so I'm going to hand it off to Andy to kind of cover the hardware.
So what makes this amplifier digital is it takes in a digital input, and ours is a fiber optic cable. And so powering it on, we can look at the front display here. It's a dual channel amplifier, and so it can only do stereo sound. But in the future, we're interested in upgrading that to about 7 channels or 5 channels. It's got a bit of a demo it plays when it first fires up. And you can kind of show what the peak indicator LEDs would look like when the amplifier is running. Moving along to the back here, Cooper, if you want to give me a hand. Just taking a look here inside. We've got our power supply off to the left side here. In the front here, we have an I/O board that runs all of our LEDs and buttons. And then in the back here is our Raspberry Pi running our web server. And then over here, it's mounted to a board that's running the amplifier and the DSP section. And so that board itself is this one here. It's a custom PCB that we designed. On this side, on the far right side, we have the digital components. In the middle, we have our analog components that are running off of our power supply, our 2,000 watt power supply. And then off to the far left here is where the Raspberry Pi plugs in. And so yes, our hope here is to create an amplifier that someone can use in a home theater market, and they can manipulate the digital signals from a website or from their couch. And so on that, I want to turn over to Coop, who did our software.
So like Andy said, I'm the one who did all the software here for the DSP audio interface. There's 3 main goals we're looking at on the software side of things. The GUI for the signal manipulation that allows the user to manipulate any audio signals coming in. The GPIO, which we see on the front panel here. And then the preset save and load system, so that when you make modifications and you adjust the signal, you can save it and then load it another time, whether it be on boot or if you have another preset already loaded. Currently, we can support up to 15 different presets through the save load feature set. And then for the actual signal manipulation that we see through the GUI, ultimately it's going to be customer's choice. So you can do as much as you want, whether that just be volume and gain control, all the way up to your DRC and EQ side of things. So for the audio files out there, you can adjust your thresholds for compression, expansion, limitation, any of those feature sets. You can adjust your attack and decay envelopes. And then for the EQ, depending on your frequency range, you'll have either 7 or 5 biquads, which are pretty cool. And then that gets really in the weeds where you can adjust your frequency gain respectively on each. But ultimately, it'll just be up to the user how much they want to interact with it, how much they want to use. And that way the software can remain as free and open as the user may want. Ultimately, there's a lot of expansion you can do with it. Like Andy said previously, we can support more channels in the future, possibly more effects in the future, like your reverb and delay. And that way, at anyone's at-home theater, or perhaps even up to like small venue scale, since we have a high wattage on the output, you'd be able to adjust whatever you need to a professional level if that is what you so desire, which I ultimately think is really cool. And it's pretty in-house with everything, since a lot of audio interfaces on the market do not support this sort of mixer interface that you're getting there, unless you get to the really high-end, many thousands of dollars, where we can, as Alex said previously, come in at a much cheaper cost with a lot better signal integrity. Any final thoughts, fellas? Covered it. Thank you.